sometimes I'll hit something where that little recording symbol disappears in the bottom left. But if you're worried about it, if you're here, I don't think you need to look at the recording. Okay. So anyway, so there's several aspects to the class that I like to do. I like to start um, with questions, right? So we'll start with questions, and it could be homework questions. It could be something in the lecture. It could be something in the homework. I don't want you to say to me, it's homework 1-1, number 7. I'd rather you take a picture of the homework question, a picture of your work, and then any kind of comment you want to make, right? And you could, of course, you could probably do it all on one page, because when you're doing a problem, you should write it down and then do the work, and then you'll check your answer by submitting it. And if you get it right, great, good for you. You could do another problem. You can go to the next problem. If you get it wrong, you want to rethink it. And if it's still wrong, don't waste your time. Ask me, right? That's my job, is to make sure that I one, we don't waste your time, and two, you get your money's worth. So homework questions or any questions like that we'll do first. I like to try and recap the previous lesson. Yes, Chris, question.
I was wondering why the assignments were due December 16th and not in order.
Oh, well, I teach the way I am, and I'm a person that I'm ADD. Okay, so first of all, and there's a joke there. ADD should be a plus in math, right? But so sometimes if I can't get homework done, I don't want that extra pressure, right? So I'm saying you should still get. So our first test is on chapter 1 and chapter 8. You should get those homeworks done before the test. That makes the most sense. But I don't want to put a deadline on it. That, you know what I mean? That if you're working, so if we have class on Tuesday and then Thursday, and then you work on Wednesday, it doesn't make a lot of sense to have you lose sleep or something like that.
Yeah, okay. So I appreciate that.
Yeah, that's just me, and a lot of teachers are not like that. But we can't change people. The sooner you learn that, the better. So we oh yes, Jackie, go ahead.
When is the test?
The tests are so do I have my first schedule up there? It would be a week. It would be given to you after our last lesson, and due back to me in a week. So you would have you're going to have take-home tests, and so I would give you at least a weekend to do them. So on every test is a take-home test, and then the final exam will be proctored.
Okay.
Yeah, so it's really an easy, take-home test. Are you going to look at your notes? Of course. Right? So, as the test should be very low pressure. And if you're taking a support course, it should be even less pressure. So, right. So if you're just getting some extra help with the math and the extra support course, if if you're in there. And so, Chris, did you have another question? Your hand's still up.
No.
Okay.
How does it?
Yeah.
How do I take it?
I think you just click it again. Yeah. There you go.
Right, thank you.
Nice. No problem. So we start with homework questions. We're going to recap a lesson, right? We have new material. Ultimately, I'd like to do at least a section or a section and a half every class. We might have some group work. So we'll try and do some group work today. Group work would mean we do a breakout room, with a bunch of questions, and we're trying to discuss with each other, how would you teach this? Or why would we want to teach this like that, right? And, for some of you, you're going to be the math teacher. For some of you, you're going to sub for a math teacher, right? But certainly in many courses, there's an aspect of numbers, and this is what we're talking about in this first course, number systems, right? There's an aspect of that that you should know anyway. And then if we have time, we're talking about some homework problems. I want to make sure I kind of visit the homework for you. In my math lab, I want to make sure we see that together so you're not shocked by anything. And then in terms of home, you're going to read. You're going to have book problems. And you're going to have the My Math Lab problems. Right, so that's our setup for the whole thing. So we got a chat here. For a test, will it be online or will we have to print them or pick them up? They'll be online. It'll be a My Math Lab test. And what I ask you to do, Daniela, thank you for asking that. What I ask you to do is take the test as if it's a paper test, right? So you're at My Math Lab. It gives you a problem. It could be two. I don't know. I haven't written a test yet. It's my first semester teaching this one. I've taught 131 before, right? And I'm kind of adopting what the teacher that wrote all this material has done. So I don't know how it's going to go, but just know I'm going to be as fair as I possibly can, right? And I'm expecting everyone to have an A or a B. It's going to be very hard to fail the class. You'd have to basically not do anything. Jackie, question?
For the reading part, is that going to come from the textbook?
Exactly.
Or are you going to get...
Exactly. Yeah, you're reading the textbook, every word. So I'm expecting by Tuesday that you read chapter 1, 1, 1, 1, 2, 1, 3.
Okay.
Yeah. And some of it won't make sense, but you'll ask me about it, right? I think everything in chapter 1 will make sense. It's about, we're talking about numbers, and I'm going to lecture on it today. So we're talking about numbers, cardinality, that's kind of weird. One-to-oneness, that's kind of weird. Base 10, that's not weird. We know that, right? Base 10. Otherwise, it's pretty easy stuff. Positive and negative numbers. Easy stuff. But like one of the things we're going to talk about today is why is a negative times a negative a positive? Anybody know the answer? Why is a negative times a negative a positive? See, this is not a difficult concept, but why don't people know it? Is baffling to me.
When I was in middle school learning that, they taught us like a song.
Oh yeah, and is your voice warmed up?
It's literally just like, it just says each of the things, like a negative times a negative equals a positive, and I forget the rest of the time it does.
Right,
so
but the question right. No, I liked the tune, and you had a good rhythm there. But we're talking about why. That's see when
that's
we're
a hard question.
Yes, it is. Until you hear the answer, and you go, "Oh my God, it's so easy." But we wanna be thinking about why, right? Why did this happen in history? Or why didn't someone tell us it happened in history? We want to, and in math, it's a little bit simpler. It's a little bit simpler to say why, right? But we're going to talk about that today. So yeah, so read the book, and you want to try and read ahead. And I know it's tough. Like for me, I'll lose my place or I'll fall asleep when I'm reading. So, but you want to try and read, and maybe even read with a pencil and paper, or write. If you can print out the pages, you can write on the pages. That helps a lot. But read the book. Okay, So we're ready for section 1.1 today. Oh, any other comments or questions for me? Because I mean, we don't have. Oh, I'm sorry, Danielle. You're going to be taking photos. You're going to be submitting the MyMathLab file for the test to the computer, and you're going to take photos of all your work and then post and then email that to me, and I'll talk about that long before the first test.
Okay, thank you.
Yeah, because sometimes MyMathLab will mark you wrong when you're not wrong, and then I get to look at your work and make adjustments.
Got it.
Yeah. And some of the answers will be written, like discussion questions. Why is a negative times a negative a positive? Kind of. You're like, I don't want that question now. Okay, so here we go. We're going to start with 1.1 today, and 1.1 is really just. Well, let me show where the book is real quick here. I'm sorry, lost. Here we go. I just go to MyMathLab, right? I think in the instructions it says something else, but MyMathLab will still get you to the right place. And then I've got everything saved, right? I've got all my passwords saved, so I'm hoping I never get hit in the head and I'll forget everything. But this particular login should stay with you for 3 semesters, right? I'm hoping you're all buying the access for 2 years, that book, because you're going to be taking Math 130, 131, and 132. And God forbid something happens that you have to drop a course, but you still have an extra semester, right, in that 2-year access to finish the sequence. And what happens when you finish the sequence? What do you do after that?
You take the test.
You take the praxis exam, yes, for the elementary school teachers for math, right? So, and you have to take several praxis exams, right? You got to take a general one, which will make sure you can read and write and that kind of thing, and then you take the subject related ones, which I only know of the math one. So anyway, here I'm in my course, right? I can see my assignments, and right, we had that chapter 0, which is just helping you. Oh, am I in the wrong place? No. So that's just helping you type in things into MyMathLab. There's a media homework, so those are videos and the author doing problems and talking about things. So there's nothing to do in there. You certainly can do that. I would say if you have a super time reading, if you're like almost like me, hate reading, you can at least watch the media and get the same aspect, right? So reading is one way to take in information. Listening is another, right? I'm more of a listener. But you'll see for every section there's a media piece about it. So actually there's no, you can see there's no, I don't know what that 1.4 is yet. So, but I'm saying up to 1.3, right? The reading up to 1.3 for Tuesday. And they're not that long, okay? So you see we do chapter 1 and then we do chapter 8, and then there would be the first test. Every 2 chapters I'm going to give a test, okay? Is it every 2 or every 1? Oh, I forget. Don't hold me on that. Just be patient with me and know that it'll be easy. Maybe I'm giving a chapter test on every chapter. I forget. Bear with me. I'll be fine by Thanksgiving. Okay. So anyway, here is the e-text, right? The textbook. And for some reason, I can't just click it once. I have to click it a second time, and then sometimes even a third time. But here's the book. Paige, this is helping.
Yeah.
And everything is slow. Everybody's doing school today, so everything is slow. I like to put the fit to page on. It just kind of is easier to read that way, and so then I'm just jumping to chapter 1 here. So we're talking about numbers in the base 10 system, and the first thing we're talking about is counting numbers. And then you can close this table of contents, and it's a little bit, you can zoom and all of that, but that's the idea. So 1.1, we're talking about counting numbers. Oops, it'd be nice if I can write. I'm using a Surface Pro to write on, and I record that screen. So we're talking about the counting numbers. So the counting numbers are the first set of numbers we ever learn. Anybody know what they are? How do we start counting?
1, 2, 3, 4, 5.
Nice. Exactly. Edward, thank you. So counting numbers are right. It's the set of numbers 1, 2, 3, ... forever, right? And so these are also called the natural numbers. What do you think?
Doesn't one of them not include 0? And
Yes,
one of them does
exactly.
0?
So natural numbers. Why do you think natural numbers?
I don't know, because counting numbers, you can't count 0 on your fingers, but it's still a number.
Yeah, why bother counting 0, right? I don't want to keep telling people I have no money. So it's just the natural way to start. It's the first brother, the second brother, the third, right, etc. So natural numbers. It's just how we count things, and we've been doing it for thousands of years, right? And so yes, that's something to think about. Is what are the other sets of numbers, right? So we have the whole numbers as well, and so now we're talking about 0, 1, 2, 3, ... right? So the whole numbers, I always think of it as the whole. It's a joke, but I can remember the natural numbers and the whole numbers. Which one has the 0? The one with the hole in it, right? So natural numbers are how we start counting, right? And so why do we need them? What's the purpose of having these numbers? By the way, the whole set of numbers that we deal with are real numbers, right? The real numbers, right? And it's funny that we say real numbers, because no one ever says, hand me that 2, right? Numbers don't exist, right? No one ever says, hand me that piano as well, but we just call them real numbers, and they're made up of rational and irrational numbers, right? Rational numbers and irrational numbers, right? So the rational numbers are the fractions, or the decimals with a pattern, and the irrationals are the decimals with no pattern, right? Never ending, non-repeating. So, and then certainly whole numbers are also fractions, right? Counting numbers are also fractions. So these numbers that we're talking about, these natural numbers, are part of the real numbers. So, but anyway, why do we have numbers? What do you think is the purpose?
I'm not sure.
That's fine. But we can have an opinion, and it can be wrong, and that's fine if we have the opinion. Right?
Wait, your question is why do we have numbers?
Yes. Why do you think humans decided to come up with numbers?
To help us keep track of things.
Good. Keep track of what, though? That's what I want to.
Of time.
You can keep track of a lot with numbers, like dates, time, quantity.
Right. Absolutely. What do you think was the most important thing?
Time.
It's daylight.
Would it be like,
Go ahead, Chris.
would it be like the value of a specific thing?
Yeah, it's a money issue. It's always money, isn't it, for us?
Yeah.
It sucks, but and that's where the negatives came in. So a positive was a credit, and a negative was a debt, right? So it's horrible. But if you think of the Egyptians, ancient Egyptians, right? They're really the creators of geometry, because they were parceling out plots of land to be able to plant, right? When the Nile would flood, right, every year. So, so you're really talking about economics, right? We used to trade. Before there was money, we would trade, but there'd be a value to it, and so we need to know how many, right? One of the things that's kind of weird in the book. So anyway, natural numbers and counting numbers. We say there's a one-to-one correspondence. There's a one-to-one correspondence with the counting numbers. Would tell you that something is countable. Okay. I'm noticing my video is lagging a little bit, but sometimes my screen will get fuzzy. If that happens, let me know. So a one-to-one correspondence means there should be a direct mapping to the counting numbers. A map to the counting numbers. So obviously, let's go. Who was first? Washington. Forget it. I'll just say Washington, Lincoln, right? Obama, right? So Washington mapped to number 1, right? Second president to number 2, third president to number 3, Lincoln to number. Anybody?
4.
No, Lincoln was not 4.
It's not like 16.
16, yeah. Obama 44. So there's a one-to-one correspondence between the presidents and the counting numbers. So it's countable, right? It's a countable set, okay? And so we say the cardinality. So if a set is countable and finite, it has a cardinality. And now this is one of the things that we hate about math. It's like, what are they using all these horrible words? But we're gonna hide this cardinality piece from our elementary school students. But you and we're gonna talk about it. But you'll see what I mean. So the cardinality, and what do I use for cardinality? I use N. I use the cardinality of the presidents equals 45, right? Oh, it's 46, sorry. Right, so it's countable. There's a map. There's, right, the first, the second, the third, the fourth, the fifth. And so now, right, we're up to a certain number of presidents. Yes, you with me? So it's countable. How do I know it's countable? It maps to the natural numbers. And it's finite. The list ends. Okay, so there's a cardinality to it, so I can tell you the number. And now listen to the difference, right? I'm counting the presents 1, 2nd, the 3rd, up to the 46th. But when I say what's the cardinality of the number of presents, how many, right? How many are there total? It's just that 46, right? And so there's this aspect of counting to a number and then saying how many numbers you had in there, right? And so there's there's a little subtlety there, but so we're talking about, and I think if you looked at the homework, you would have seen this one-to-one piece and go, what the hell is that, right? And so like we'll look at one in the lab today. So more one-to-one talk here. So let's say the set of houses and then people. This is pretty stupid, but this is the way they're trying to say to it. So I have a set here and a set here, right? So this is set A, this is set B. And the question is there a one-to-one correspondence here? For each house, can I map to one and only one person? And for each person, can I map to one and only one house? And have both sets completely accounted for, right? So this one-to-one aspect is for each X, there is one and only one Y. And for each Y, there is one and only one X. And so this is what I mean to be one-to-one. And if that set is finite, right? So is this particular piece I'm looking at here? Is this one-to-one? Is this piece that I'm looking at here one-to-one?
Yes.
Yes. And so what's the cardinality? What's my cardinality here? What pair? What's my number of pairs that I'm matching up here?
2.
2. The cardinality is 2. It's that simple, right? So counting and cardinality, there's a subtlety there, right? The number 2, when I'm counting, is me matching. When I say 2, it's the number in the total set, right? And don't overthink it, right? Don't overthink it, and know, if I asked you this on a test, if you can map it, you got to put down your interpretation of it on whether your formula sheet or in your notes, right? If there's a map from A to B and a map from B to A and nothing left over, right, then we're good, right? That's what we're talking about. So let's look at a homework question like that, okay? How are we doing here? We going at a good pace? Everybody comfortable with the pace?
Yes.
Nice.
Yeah.
So I'm going to assignments, right? I'm in my math lab. I go to my 130 course. I could see, like next semester, you'll go back and you'll see your 130 course, and you'll also have your 131 course, and you'll be able to access them as long as you want. So I'm going into my my first homework here, 1-1, the counting numbers. And I can jump to any question. So there's 13 in this one. They really shouldn't take too long. And you can always do some of them and then close it and it will remember. And you can do things over and over until you get them right. But here we're talking about cardinality of these particular sets. So we don't have to look at all of them, right? So, but let's...
Yeah, this is the
Yeah,
question.
yeah.
It was just like this when I went on there and I was confused.
Yeah, I don't blame you. I don't blame you. So, and I want to just want to be able to, because I'm going to write, I'm going to write things down as I do them. So I want to be able to, I want to be able to see both screens here, kind of. And so I'm just going to do homework, right? So I'm doing homework 1, homework 1.1, number 1, and I'm asking for, so this is 1A, right? And I'm asking for, A is the set of all x's such that x is a counting number. Okay, the counting numbers are a bold N, and 21 is less than x, which is less than or equal to 30. So that equal sign is telling me, do I include 21 or do I not include 21? So the question is, do I include 21 or do I include 30 or do I include both?
You include both.
Okay, so if it was both, I would need that equal on both, right?
Yeah,
so
so you could do 30.
right. So the equal means include it. The less than means don't include it, right? So I want to not include that 21 in my counting. So I'm basically going, there it is. I'm going 22, 23, 24, 25, 26, 27, 28, 29, 30. So what's my cardinality of N, of set A? How many numbers did I have? And you see, I kind of grouped them in twos, so it's easier to count. 2, 4, 6, 8, 9. So that's it. So figure out what they're asking you to count it, right? And then you've got your answer. So we can just, I want to just cheat a little bit because I'm lazy. Oh, I can't cheat, but I can put the answer in. When I open mine, I can cheat. So I checked the answer, and it says it's talking about some kind of cleaning, kitchen cleaning fluid. I don't know why it says fantastic, but okay, yes, I got it right. And then so I can after I do the whole answer, I can do another one like it. It will change the question for me, or I can move on, right? The second one is a little bit strange, but I want all the natural numbers that x plus 8 equals x for, right? I want all the natural numbers such that x plus 8 equals x. Well, that's a little bit weird, isn't it? X plus 8 equals x. I want all the natural numbers such that x plus 8 equals x. Do you remember solving equations? Do you remember doing this? I really want to get all my x's on one side, right? You remember doing this at all? So I'm going to subtract x from both sides.
Yeah.
Yeah, and so these guys are going to cross out over here, and then what do I get? X equals what? X minus x is what?
0.
0. Is this true or false?
It's false.
Definitely false, right? So it can't happen. It cannot happen. So what's my cardinality? How many numbers in this set exist?
0.
0. So n of b is 0, right? So the thing is, I'm trying to say, right? Is there a mapping to the natural numbers? Well, I didn't get any mapping, right? So there's nothing in the set. It's empty, right? If I do get a mapping, if I can count those numbers, right? Okay, fine, count them, and then tell me how many there are, right? So anyway, that's one type of problem. I guess the key here is you being able to read this. What's the set of C here? Reading on my screen, the set C is the set of all x's, so all numbers, such that the numbers are, what kind of numbers?
natural numbers.
Natural numbers. So like a 1, a 2, a 3, right? Such that x minus 8 times x minus 2 equals 0. Do you remember all that factoring hell we've made you do? Remember all of that?
First,
Factoring?
inner, outer.
Yes, all the four-letter F word. Foil. It's not my favorite four-letter F word, but what x's make that 0, that third set? If I put a number in for x, what would make that 0? So this was homework 1B, right? 1.1B. Homework 1.1C is x minus 8 times x minus 2 equals 0, right? So I'm asking you, what number would I put in there that would make this true? Just your gut on it. What number could I put in here to make it? So what about x is 8? I get 8 minus 8 times 8 minus 2 equals 0. I get 0 times 6 equals 0. Is this true?
Yes.
Yes. What's the other number that would work?
2.
Yep. So the answers are 2 and 8. And what's my cardinality of that set? 2. It's 2 numbers that make it true. So just jumping on, it says, oh, you haven't completed it. I know I haven't completed it because I don't want to. So I can have a set that's 1-to-1, but not countable. For example, can you count the natural numbers? All of them. Can you count the natural numbers? Can you tell me what the last natural number is? And you might say a Google, and I'll say a Google plus 1. And then you'll say a Googleplex, right? A Googleplex plus, and I'll say plus 1. So can you count the natural numbers?
No.
No, there's too many of them, right? But do they map to themselves? Right? So that's a weird little subtlety here, right? So I can have 1-to-1, but uncountable. Right? So if I look at my natural numbers, can I map them to the natural numbers? Well, I'm talking about the set 1, 2, 3, forever, right? And then I'm going to map them to the same set. Do they map up? Do they match up? Can I map 1-to-1? Can I map 2-to-2? Can I map 3-to-3? And then can I go backward? Remember, I have to be able to go backward. And doesn't everything get mapped once? So countable. I'm sorry. Oh, so that means 1-to-1, but there's an infinite number of them, so it's not finite, right? There's a difference between finite and infinite, but still we want to be able to see if they're 1-to-1 or not. It's I know it's a headache, but anyway, look at this. It says decide which of the following sets are finite. The number of men in 2008. I mean, what's the world population? What is it now? World population right now. I should know, but I don't know. I don't know why I should know. Who's got a magic box? Google the world population right now.
I think it's like 7 billion.
7, yeah, it's going to say 6 something billion, right? So
Siri told me it's 7,846.
nice. Could we be wrong a little bit? And that's
Yeah.
not Siri. Siri, not from the class, right? Siri, that joke must be getting old now for a couple of years. So it might not be correct, right? But it's still finite. Yes, it's finite. Let's get to one with the maps. Here's one with the maps. So which of these is a one-to-one set here, right? So how about one? How many elements in set A? You can all see my screen, correct?
Yes.
Yeah. How many? There's 5 elements in set A, right? In the first set, right? How many elements in the second set, set B?
5.
5. And they're all unique, right? There's no repeats in set A. And there's no repeats in set B. So I can map from one number to one letter or one letter to one number, and that's what it means to be one-to-one.
If the letters or numbers repeat, does that make it not one-to-one anymore?
Yes. So we're repeating. Remember, my statement was for each X, there's one and only one Y. Right? So that's a good question. Let's look at that. What happens there? So I don't remember what numbers they just said, and I don't really care. But I'm just going to do a set of 3 numbers, 1, 2, 3. I'm going to map to ABC. Why not? Jackson 5 song, right? So 1 will map to A, 2 to map to B, 3 to map to C. So I said for each X, there's one and only one Y. But then I have to make sure I can map it backward, and I can, no problem. Right? So everything gets connected, going left to right or right to left, up to down or down to up. Okay.
All right. I wanted to know, what was Jordan's question again? I didn't really hear her.
What if we had a repeated number?
Okay.
And so that's, yeah. So this one is one-to-one, yes?
Yes.
Good, but what if we did this one? Right? Now, 1 is mapping to A and 1 is mapping to B. So the problem is, what's my map from 1? It can only be one answer, right? But I've got 2 answers out of this. So this one's not one-to-one. So really the essence is that this first set is written down wrong. The first set is really written down wrong. It should just be 1, 3. You don't want repeats in your set. Right? The counting numbers don't contain 1 and 2 and 3 and 4. They just can contain 1, 2, 3, 4. Right? So you won't see a set with repeating. You shouldn't. But the basic idea is, can I map each element to one and only one element of the other, and vice versa? I know it's annoying. We got to give in sometimes to life. Give in. Okay, we're ready to talk about our next little aspect here. So we're still in 1-1 here, but we're now talking about the base 10 system. And we talked a little bit about this, I think, yesterday or Tuesday, right? Base 10. And so why are our numbers base 10? Because that. And you could say, well, wait a minute, I gave someone the finger on the way to work today. So no, it's base 9. No, it's still base 10. Right? Just from thousands and thousands of years of us living with 10 digits. And there's some beautiful ways to do arithmetic with your hands, right? And there's some nice connections about, like, the way you say 6, right? This is in one culture how you say 6, and 6 is a perfect number. 1 plus 2 plus 3 is 6, and 1 times 2 times 3 is 6. And so that's why the wedding ring goes on that finger. Perfect. It's supposed to be perfect. Of course, don't ask my ex-wife about that. But so there's like these beautiful little connections to why we do things connected to numbers. Numbers would, like for ancient Egyptian times, geometry was philosophy. It was like a connection to God, not so much a torture of students. So, but anyway, we're base 10, and because of the fingers, right? So, what does that mean? Base 10 is, like even if we wrote a decimal, right? Every place is based on a unit of 10. So this particular piece here, I'm going to put some slashes through it. Right? And so this 3 here is really a 30, right? So this is a 10 to the 1 power. This is 3 times 10 to the 1 power. And the 7 is really a what? It's 100, right? $100. So that's a 10 to the 2, right? 10 squared is 100, right? And the 5 is a what?
1,000.
1,000. That's 5 times 10 to the 3, right? 10 to the 3 is a 1 followed by 3 zeros, right? There's the connection between the exponent and the number of zeros. What about the 2? That's a 2 times
10 to the 0.
10 to the 0. 10 to the 0 is 1. I had explained that the other day. The book is just often writing that just as a 2. And then what happens to once we go past the decimal? This is a 1 times 10 to the minus 1, right? So that's 1 over 10, right? So this is a 10, or 10's place, right? 10's place, and this is a 10th. It's hard to say that, or the 10th's place. Right, and what about the 4? The 4 is a 4 times 10 to the minus 2, right? So we're giving an exponent to the value of the 10 in each case, right? So when we first learn to count, when we first teach how to count, right? Right, we'll often group in tens, right? So if we can box a 10, we know we have a 10 and a 1, right? And so then we've got our 11, and that's if we can group in tens, right? So if we have 10 tens, we know we have 100. So this grouping happens pretty natural, right? So once you get to 10, okay, hang on to that. Now start counting again, right? Kind of idea. And it'll work into our number line as well, right? So if this is 0 and this is 1, we can cut 1 into 10 pieces again, right? So 2, 3, 4, 1, 2, 3, 4. And now each of these, right, is now a penny, or sorry, a dime, right? So the 10 dimes, so this is 0.1, 0.2, 0.3, right? So we're counting up dimes there, right? So 0.9, and then once I get to 90 cents, then one more time will get me to the whole. So that whole idea of tens is grabbing sets of tens or cutting things into tens. And why are we doing that? Because of these, right? So that seems easy. Am I right about that? It's not a difficult concept to grab there. But don't let me force you to say yes. I would like an honest opinion. This seems very easy compared to the cardinality and the one-to-oneness. Am I right about that? Is anybody awake?
Yeah,
this?
Yeah.
Yes.
Okay, thank you. 10, 14, 17. I got to take a attendance real quick. Once I put the attendance in my book, I delete the pictures. Believe me, I want my memory for my music. So here's a typical problem, right? So this is homework 1-1 number 4. And so what we're talking about is being able to write this, right? 9 times 10 to the 4th plus 9 times 10 to the 3rd plus 2 times 10 to the 2nd. We want to write it in its normal state, right? 9 times 10 to the 4th, 9 times 10 to the 4th plus 9 times 10 to the 3rd plus 2 times 10 to the 2nd. And they're asking us what number is that. So I'm kind of going, okay, 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the 1, and I want to go all the way down to 10 to the 0 in the ones place. And then I'm filling in where I can. So this one's going to go here, this one's going to go here, this one's going to go here. What should I do with the rest? Zeros, right? So 99,200, right? So pretty simple. So you're going to have to expand things out or compact them back in with base 10 or the actual words, right? And so how would I say this? I could also write this as 99,200. So really easy. I'm sorry it's too easy. I don't mind when things are too easy, but you can't let them get you annoyed. And when things are too hard, it's the same thing. You're trying to minimize. You're happy because you got a parking space. You're mad because someone keyed your car. You're trying to minimize both of those, and then life is easier. So same thing with math homework. Something difficult, fine, ask for help. Something too easy, great, get 100 on it, right? So expand this one. I think we can do this one probably without me writing. But 2 times 10 to the what? So I'm going to type.
3.
Yep. So 2 times 10 to the 3. Notice there would be 3 zeros after that 2,000, right? So I can do 2 asterisk 10 raised to the 3, right arrow, plus 3 times, right? I'm using the asterisk there, times 10 to the caret, right? The up arrow, 2, yes?
Yeah.
Plus 7 times 10 to the 1. I can just put 10, and then I can do plus 4, and it should accept that. Pretty easy, huh? I think that's the whole homework. So we're actually done with 10-1. Yeah. Oh, I guess the null set is the one thing I had to talk about, right? Let me just make sure I mention that. So we had the set of x plus 8 equals x, right? And the solution set, right? So question, answer was nothing. So I can write that as an empty bracket or the null set. So it's a null set or empty set. Nice. So that's 1-to-1. That's section 1-1. I do want to talk about 1-2. We got a little bit of time. We looked at some homework problems, right? So kind of looking at our list here of what the class is like, right? We had our new material, right? We did some homework problems from it, right? Whenever I say this new material, it's me going through the kind of things that we're talking about in that section. And then there is a group work piece on this, but I want to just jump to the next section because it's really quick. So let me jump to the next section, and then we'll try and do a little bit of group work today, just so you see what that is like. Okay. So I think our list of homework for Tuesday. Right. So for Tuesday, I think it's the 7th, right? We're reading 1-1, 1-2, and 1-3. 1-3 is you're reading ahead, right? But you'll see it's like rounding and counting, comparing numbers and things like that. It's not difficult. We are in my math lab, my MML. It says on the schedule. We're gonna do 1-1 and 1-2. And for our book work, right, for the textbook, I think we can get away with just 1-1 because I want you to. So there's 3 questions there. I think it's 2, 7, and 8. I'm just double checking here real quick.
It's 2, 7, and 9.
2, 7, and 9. Thank you. And again, this is all here. I'm going to share my screen here. I go into Montgomery College. I access my MC. Oh my God, it's so slow. I go into Blackboard, putting myself to sleep. Find my class. I hate that this thing gets collapsed. The side menu. You annoyed by Blackboard as much as I am? The side menu disappears when the screen is small. And I go to the schedule, right? That's where I'm finding everything. And my schedule's just a little bit off. I'll adjust over the weekend. Oh my God. So, where did I go? Did I go in the wrong? Yeah, I did. I went in the wrong class. Sorry.
I think that's Math 165.
Yeah, I went in the wrong class. Sorry. Math 130. There it is. Into the schedule. And so here's our my Math Lab 1-1, my Math Lab 1-2. You see I'm a little bit behind schedule, and the book homework in 1-1. And the book homework in 1-1 is right page 12, 2, 7, and 9. Okay. There are practice problems here, but I just want you to do these written down. Right, and then Tuesday we'll talk about turning things in. You're not going to turn that one in just yet. So, but I want you to look at those, and you'll see those questions I ask you to do are more opinion, right? Why are we doing this kind of thing, right? And so once you read, you should be able to get it, or you'll catch some of it when I talk about it in the lecture. Oh, I lost somebody else. Let me take attendance one more time. Okay. So yes, we're comfortable. We know what we're doing this weekend. So this was number
Yes.
279.
Yes.
So yeah, 2, 7, and 9 on page 12. And you'll see it's like a short a sentence, a couple sentences, small paragraph kind of thing on those problems. Okay. And then I'll show you the solutions on those on Tuesday. Okay. 1, 2. And then if we have time, we'll try a quick little, let's do the group. Let's do a group work thing first. And this group discussion is going to come from Blackboard in handouts. So I've only got the first one up there. So you feel free to open that so that you have it. And this is our kind of our like little discussion pieces that we're going to do. So it's from 1-1. So I'm gonna put everyone in breakout rooms. So 1, 3, 6, 9. So it's going to be 3 or 4 of you in each room. And we're gonna let's see if we can discuss. It's kind of silly, right? So I'm just asking you when we do these. I'll say, all right, let's get in a group and discuss. And then when we come back, we ask someone from each group to volunteer kind of an answer, right? So let's see how we do that. I'm not going to leave you in there too long. So, but you're going to just try and discuss each problem, right? Or maybe even write on the page, okay? And then we'll come back and talk about it. So I'm going to open up breakout rooms. I'm going to randomly assign you to breakout rooms. And then just say accept, okay? And then when I'm going to close the breakout rooms, it'll give you a warning that the breakout rooms will close in a minute type of thing, okay? So can you all open that document first of all?
How do you get to that document?
It's in Blackboard in our classes. On the sidebar, you should see documents. Jahira, is that Jahira?
Yeah.
Yeah. So in Blackboard, in our class, and then on the sidebar, you should see announcements, documents, schedules, syllabus, right? So it's in the documents folder.
In the documents folder. Mine doesn't say documents.
Oh, it's handouts.
Course content.
Hmm?
I went into course content and then handouts.
Yeah, you would have to go into course content first, and then there's a section where it has different things, and then you would go to handout.
I don't have course content on mine. That's weird.
Yeah, I just see handouts.
Mine just says handouts. I don't know what. So announcements, handouts, schedule, syllabus. So it's on that. I guess that sidebar is course content. I don't know, but handouts.
Okay, got it. Thank you.
Nice. Okay, I'll stop my share. Everyone else okay? And create the breakout rooms. So I'm going to create, how many students do I have here? Okay. I'll do 4 rooms. Okay. So you can talk to each other. You can share your screen. I think you can probably talk it through today. But here we go. So accept your breakout room, and I'll probably jump in. I'm not really here.
Wait, Professor, which numbers are we doing?
All of them. All of them.
Oh,
You probably won't get to them all, but
So does everyone have the handout open?
yeah.
Yes.
Okay. So we can start with number 1. It says, what is the difference between the set of counting numbers and the set of whole numbers?
Counting numbers involve 0, right?
I think that would be the natural number.
yeah. What was my joke for the whole numbers?
Oh yeah, no, the whole numbers have the
Has-
0,
has
and
the
then
whole-
the counting
right,
numbers
right.
doesn't have the 0, right?
Right. Nice. I'm not really here. I'm just eavesdropping. How are we doing?
Just looking at the problems.
It's good energy. Good energy in the room. Did we do number 1 yet?
I think we skipped number 1. We did number 2 first.
Okay, fine. So number 2, what'd you all say?
That they all have a 1-to-1 ratio except for number 3.
Nice.
Yes.
Nice. Awesome. Good. Keep working.
Up to 5, but I don't know if they 100% know to identify this as 1, this as 2, this as 3.
Yeah, I agree. They can't determine if each one and the whole thing is 5 yet. I would agree with you.
Nice. Oh, you're on number 4 already? You're on 4, working on 4
Yeah, I
already?
agree with that because they
Nice.
can't really say which is 1 through 5.
There's how to
textbook, but he just has that on Blackboard.
Where's the textbook though? In my math lab.
Sorry about that. I meant to close the. Oops.
Professor, you're muted. We
Yes,
can't hear you.
I'm sorry about that. I meant to close the breakout rooms and I closed the meeting. Not too smart, Robert. Sorry about that. So I liked the discussion that was happening. That's good. At least it's a little break of the content, and you know, at least you don't have to listen to me for that amount of time as well. Sorry, I accidentally closed the meeting instead of closing the breakout room. It's not the first time it's happened. So I want to do one more thing. We only have about 14 minutes left. I don't even think I want to stay for the whole 14 minutes, but I want to look at the next set of homework because I've already talked about some of the aspects on it. The only thing I haven't talked about are the negative numbers, right? I guess a little bit of the number line as well, but let me get back in there. So give me 1 second here. And of course, I was recording the breakout sessions. I shouldn't do that either, because then that's a bunch of dead space on the video. So the main thing about 1.2, and we're talking about negative numbers, is a negative means opposite. And of means multiply. So the opposite of a -2 is +2. And so if you think back on that number line that you had, right? So there's my +2. If I walk from 0 to 2, I've walked 2 steps. If I walk from 0 to -2, I've walked 2 steps, but I've walked in the opposite direction, right? And so that's what we're talking about. Do you remember that time when you had a number line on your desk? Did you have that as well, or is that just me? You had a number line taped to the top of your desk in probably
had that before.
in 4th grade or something, yeah. And so, but negative meaning opposite, and of meaning multiply. The opposite of a -2 is a +2. And there's opposite is a funny word. I really think it only exists for numbers. Because what's the opposite of right?
Wrong.
I was going to say left. And what's the opposite of up?
Down.
I was going to say, well, it's a Pixar movie, so I don't really know the opposite. And then what's the opposite of peanut butter?
Jelly.
No, not true. Right? So the only thing that are really that are opposites are numbers. Numbers have opposites. And we're just talking about 2 steps to the right or 2 steps to the left. So that's the subtlety of why a negative times a negative is a positive, because a negative means opposite. It really originally started, I don't know how many years before, or at some time 800 AD or something it's talking about, but it was debt. The positive numbers were worth or wealth, and negative numbers were debt. So owing somebody or not owing somebody, right? And everything was always trying to, right, have that balance out to 0. So if you had 2 cows and you owed 2 cows, right, there it is. You really have, you're back to 0, back to that origin. So I think I'm not going to have much time to talk about 1.2 today, but you're going to read it, and I don't think you'll have much problem with it. But we'll start the next class with homework questions. So let me look at a couple of problems from 1.2, and then we'll finish up today. So I'll share my screen again. Anyway, I liked the discussion. When I dropped in, I accidentally closed the meeting instead of closing the breakout room, so I apologize by that. I guess someone else thought that the class was just over, and that's fine. A couple students didn't come back, that's fine. So decimals and negative numbers are what we're talking about here. So I've already kind of talked about decimals a little bit, but not much. There comes somebody back. So let me share my screen.
Yeah, when you accidentally ended the meeting, we all like talked on the Discord to figure out if we should come back.
It's funny. I don't care. You know, if I make a mistake, it's fine. Doesn't matter. So I'm not going to hold you responsible for my error. Am I still sharing my screen? I am not. Is that correct?
Yeah, I don't see it.
Okay, I'm working on it. Here we go. So we're comparing positives in the first case, right? 22.5, 22.5, 22.5. They're all 22.51, right? And so I'm looking at the very next number. What's the biggest? I've got a 3, a 3, a 4, and a 3. So I already know that the 22.514 is the largest number, right? So you just gotta. I like lining them up. Right, I would do something like just line them up. So I've got 2, 2, 5, 1, 3, 9, 5, 2, 2, 5, 1, 3, 8, 7, right? 2, 2, 5, 1, 4. Here's my dog. 2, 2, 5, 1, 3, 9. So I can already, I can see that they all match up, right? Up to 1. So now I'm really just comparing 395 to 387 to 400 to 390, and so it's pretty easy to do that. And then negatives, of course, I'm going to rank them, right? I always want to think of the number line, and so we're using the greater than symbol. I always remember the less than symbol. That's my left hand. L, right? It looks like an L. So my numbers should always be larger to smaller from right to left on the number line. Anyway, I'm kind of just asking you to try some of this on your own here. Just going to go through a few of this. So there's more powers of 10 here, right? But what's the 5? 5 times what? 10 to the what?
To the negative 1.
To the negative 1. And then plus 7 times 10 to the negative
2.
Yeah. Right? So etc. So it's not much new in section 1, 2. So read that first, right? Look at the example problems they do and then try that homework. All right, nice, good work today. I'm happy with the discussions. There's nothing really to write on that, but you'll see the homework from the book will take in some of those things. Which student is counting correctly? Why should you have them group in tens, kind of thing, and all of that. So have a great weekend. Have a safe weekend. I'm gonna now actually close for real, but I'll hang out if anyone has questions for me.
Thank you.
You're welcome. Have a great weekend.
Thank you. Have a good weekend.
Thank you.
Thank you, Professor. Have a good weekend.
Thank you. You too.